If you'd like to turn your camera off, you may do so.
Yep, it says it's being live streamed.
We up?
I did it.
Are we live, Lou?
Yes.
Okay, welcome everybody to the Rittenhouse Astronomical Society. You stumbled in here on our YouTube live feed for our monthly event. Rittenhouse Astronomical Society is arguably one of the oldest astronomical societies in the country. We're based over here in the Philadelphia area, originally out of the Franklin Institute. More recently, we've been a lot more involved with our observatory, that we are working with a new company out in Lancaster, about an hour and 50 minutes right here from the downtown Philadelphia. And that company is now called Constellation. So if there's any people out there from Constellation, welcome on. We are the educational unit of your observatory, the Orion Observatory, that's located out at just below Lancaster, Pennsylvania. So welcome everybody. Later on in the evening, I'd like to share some good news with you. I'll tell you a little bit more about what's going on at our observatory. I'll tell you how you can get involved, because we're looking for lots of volunteers this spring. We're looking for people to get involved with us, and we'll be sharing more of that information with you towards the end of the meeting. It's been very interesting with us. Before we start at the YouTube tonight, we have something that we call Preamble. We actually start about 10 or 15 minutes earlier. And what we do is we share a little bit with our members who we are. We now have enough membership that have come on since the COVID virus that there's people here who might have never met us in person. There's people here who would have met us out at originally what was Muddy Run Observatory and never have seen us in action at the Franklin Institute. And a majority of the people here are still probably from the Franklin Institute, and some of them have never made it out to Muddy Run. So it's kind of a trick to take this society and get everybody to feel that they're a community, but the community is really kind of centered now around the entire southeast area of Pennsylvania. So some of you don't know the next person I'd like to introduce. His name is Dr. Lydell Nunn. Lydell comes to us about a year and a half back, and he came on scene bringing not only his expertise, but he also did some amazing generous donations to the astronomy gear that we have in Dome 2 for our astrophotography. Not only did he bring us an amazing camera, I believe he was involved with some needed filter sets that we were after also. So Lydell, if you've been out to Muddy Run, you've probably met him, or you might know of him. I've also met both of his sons, who we might even get involved as volunteer assistants this summer, for the observatory. It's a practice that we've done with the society that if somebody can reach out and get a guest speaker, we let them do the introduction. So Lydell, when I say he brings expertise to us, those of you who've been with us and been watching the meetings, you've actually seen him as a guest speaker with us in the past, because he's had multiple publications in Sky and Telescope magazine, an amazing astrophotographer. So Lydell, you want to take it from there and introduce our guest speaker tonight?
Thank you, Ted. Appreciate it. It's a pleasure to be here again tonight. I'd like to introduce our guest speaker, Sean Walker. I first met Sean about 2 years ago, about 3 years ago, at the 2019 Northeast Astro Imaging Conference. It was actually kind of post-conference event. A couple of imagers were getting together, and Sean and I had some mutual friends. And he introduced himself and informed me he was the associate editor at Sky and Telescope magazine. And I believe at that time they were in the process of, the magazine was in the process of being bought out by the American Astronomical Society, which now governs the publication. At any rate, Sean and I hit it off and became friends on Facebook, and interact periodically through there, because there's been no Northeast Astro Imaging Conference for the last 2 years because of the pandemic. But Sean has several interests in astronomy, including the MDW Observatory. And one of their pet projects, their passion projects, I should say, is a all-sky Hydrogen-Alpha Survey. And so that was something that I had a lot of questions about, and Sean was more than willing to come in and speak with us about the survey. So Sean has several interests in astronomy.
Sorry.
So that's okay. And so without further ado, here's Sean Walker from Sky Telescope Magazine.
How you doing? Anyway, thanks for that, Lydell. First off, well, yeah, I'm an associate editor for Sky and Telescope magazine, but in my spare time, copious amounts of it now, I do a lot of imaging projects amongst different art projects. But I'm here to talk to you today about one of our big projects, and that's the MDW Sky Survey. Here we go. Hang on just a moment. Can you all see that, my screen?
Yes, we can.
Yep. All right, cool. Anyway, so we're involved in a project where we're mapping the entire sky. Here's a little bit about how it came together and what it's doing now. Anyway, if this would go forward. Anyway, the MDW Sky Survey is, we have our own website for it already. It's kind of odd that we launched it early, but you'll see why in a few minutes. The survey is a partnership between 3 amateur astronomers. David Mittelman, who was formerly of Dover, Massachusetts, Dennis DeCicco, my former co-worker at Sky and Telescope, who lives out in Sudbury, and myself. I'm in southern New Hampshire. We were all members of a club together, the Amateur Telescope Makers of Boston, and we know each other through astrophotography and the magazine. Anyway, well, our project came about because, well, we wanted to map the entire sky at a certain resolution. Right now, we're concentrating at using 5-inch telescopes, astrophysics telescopes, to record at 3.1 arcsecond resolution per pixel. All right, and that's relatively high resolution. It doesn't sound high resolution to a lot of astrophotographers, but in the sky surveys, this is actually pretty high resolution. Anyway, our goal is to do 4 hours of cumulative exposure per field. Anyway, and the project grew out of several interests. Myself and Dennis DeCicco were constantly, well, interested in imaging the sky with wide field cameras, and as digital detectors grew in size, it became a lot more appealing. One of our first projects you might have seen in the magazine, wow, 13 years ago, was a mosaic that we did spanning 4,000 square degrees of the winter Milky Way. And this was the fruits of that labor. This was using a 50mm lens and shooting it's kind of grew out of a small corner of this project. What you're looking at here is Orion in the lower middle, and to the right is a big object that's called the Eridanus J. There used to be. It's part of the Eridanus Orion loop. This is all associated with the same nebula that's giving birth to the Orion Nebula. Anyway, it's relatively close to us, but it was rarely seen at such wide angles. If you look to the to the right, you can see Taurus and the Pleiades. That gives you a really good sense of scale there. Anyway, and this is how it actually fits on the whole sky. So we're looking at a pretty good swath there. That went really well. Yes.
Take us back 2 pictures real quick.
Sure. Oh, sorry.
I was just looking at up the sky, all sky view. One more back. Thank you. Okay, everybody. I think.
Am I too far back, or? I can't hear you. Anyway.
Don't know what happened to Ted.
Yeah, we lost you. Ted, you're muted.
But
I'm
we
back.
can
Okay, I'm back. I'm trying to do something fancy here for us, but I know some of this too. So most of our members might not see it. So right there. Oh, go back.
Was this the one you were looking for?
No, one back.
All right, there you go.
There you go. See right there. Can you guys see it? I've just circled it. There's Taurus the Bull right about there. Okay. Those of you who are beginners with us out here, Orion's belt, if I'm not mistaken, it's going to be like right down in this area, right about here, because I believe that's the loop. Is that Bernard's loop right there, Sean? The
That's Bernard's loop. Yeah.
Okay.
Oh, yeah.
So just give you a little orientation. We have some beginners that have never seen these before. And one of the easiest areas to see is Orion. So Orion, the hunter, is this whole area right here. The belt region I've highlighted there. And there's Taurus the Bull. And he last talked about the Pleiades. There's the Pleiades right there. And for you real beginners, you just line them all up. The belt can point out the Hyades and the Pleiades. Sorry, Sean, go ahead. I just didn't want to miss the opportunity.
No problem. While we're still on this image, briefly, if you look at the nebulas in that look like it's making a diagonal line from the middle of the top all the way to the bottom left, that's looking directly along the plane of the Milky Way. And those are further back than the Orion Nebula is.
I think I've got it there. Is that about it? Is that the plane of the Milky Way highlighted? There you go.
Exactly. All right. Can I continue?
Okay. Go ahead to the next one.
All right. Well, I showed you. Can you get? All right. There you go.
Let me get clear all drawings. Come on. There we go. Got it. Keep going.
That really went well. So we decided to go higher resolution. We stepped up to a 110 millimeter lens and planned this out a lot better. Our goal again was 4 hours per frame. It doesn't sound terribly deep, but there's only so many hours in the Northeast in the winter where you can image, as you guys know, in Philadelphia, outside of Philly, right? Anyway, each night, this is the camera, by the way, on the left side with the apogee. You see the fans on the left there. That was the setup with the camera lens. Anyway, Dennis shot this over the winter, and this was the second version. As you notice, first off, it looks less coarse. The stars are smaller because we're using a larger aperture. And this is kind of key as you go forward, because the larger the optic you use, the more you can kind of see beyond the stars that are filling your field here. Our next version here was a lot bigger. We went all the way up into Cassiopeia there. You see on the top, very top left, right, sorry. And you can just see the double cluster, I believe, right there on the top right edge. You want to circle that, Ted?
I'm trying to. I can't find it. Anyone else want to try it? Go ahead. I'm looking around. Am I looking around this area right here?
No, to the left.
Got it. There, right there.
Right on the edge.
There you go. Two open clusters side by side. Beautiful.
Yeah, that kind of gives you an idea how big of a swath of the sky we're looking at here again. But beyond that, this makes a really nice picture of things. But what we're really interested in is the really faint stuff on the outer edges, limits of this field here. Do you see the really faint tendrils of nebulosity going off?
Wow. Yes.
Anyway, and this is the whole thing over Dennis's house where he shot it, and makes a nice little picture.
Wow.
That is nice.
Okay, that's actually registered to the stars of the photo that was the base photo there. So that's really to scale.
Wow.
Okay. After finishing that project, Dennis, myself, and David were kicking around ideas of how to continue our H alpha work. All right, what more could we do? Well, what we were thinking is that, maybe doing, the whole sky, because most of the all sky surveys that are available publicly are very low resolution. You guys, people with planetarium programs that can switch the wavelengths that you're looking at might be familiar with this view here.
Yes.
It's popular in most of the planetarium programs. This is the Virginia Tech's Spectral Line Survey by Douglas Finkelbeiner. Anyway, that's basically, that was done with, I think it was done at radio wavelengths with very small optics in general. But that's, as you can see, it brings out a lot of the faint outer regions, but it's very coarse. I mean, the resolution on this when you zoom in is well, our camera lens shot at the first thing was higher resolution.
Okay.
Okay. So we began to experiment with new optics. We tried a 200 millimeter, that's an 8-inch Officina Stellare Riccardi-Honders astrograph. It's a complex Cassegrain type optical system designed specifically for astrophotography. And in the summer of 2015, Dennis shot a 30-panel mosaic testing this set out of. So this was the result for that particular project. Looked pretty good. I was fairly happy with it, but it had its problems. Okay. As you can see, this is zooming in on the Veil Nebula. It really shows you a lot of the faint outer nebulosity in the image. But there were a few limiting factors. Obviously, our New England skies, we don't get very many clear nights. Okay. But the detector that we're using, a 16803 CCD detector in that Apogee camera, it was larger than the corrected field that the Riccardi-Honders produces. So the stars at the edges of the field of view were particularly distorted and going out of focus. So you weren't really taking advantage of the whole field of view there properly. Anyway, also reflective optics, a Cassegrain or a Newtonian or whatnot, always require minor recollimation with changing temperatures. And if we're trying to shoot the entire sky, we could be doing it for years, and we can't really afford to stop, recollimate every time. While regrouping to discuss the results, of course, Dave suggested that we not limit ourselves to only a certain region of the sky, and we could perform a systematic survey of the sky, shooting remotely from a dark sky location using just off-the-shelf technology. In 2016, when we started this project, it was kind of a big deal. Now this is pretty common. You can buy this stuff and set up a remote observatory pretty much anywhere. David was a member of the New Mexico Skies Astronomy Village, and he had several telescopes down there, and he had founded several different observatories for colleges and for his own private use. These are some of Dave's endeavors. Our survey scopes are seen on the left there, but he also has in the Mittelman Observatory, he donated to the Middlebury College, founding their observatory and seating their astronomy professor each year. He also has a few telescopes at his house. Anyway, he has a 20-inch plane wave. Anyway, Dave has taken a lot of astro images himself also. This is Dave. Actually, this is when he was planning the observatory at New Mexico Skies for his really big baby there. This is his one of his final projects, which was relocating a 36-inch Böhler-Schivens Newtonian down to New Mexico and making it a remote telescope available for college students to use. Anyway, this is to give you an idea how big that guy is.
Wow.
Wow.
That's amazing.
Yeah. Anyway, so the planning commenced for our project, the survey, in the fall of 2015. We decided on 2 astrophysics 130 Starfire refractors as our primary instruments, which kind of were difficult to acquire 2 of them. It's a little tough to get one, but we pulled some strings and managed to scrape up 2 of them. Anyway, and we designed this around 2 FLI PL 16803 CCD cameras. Okay, they were a really large, was it 38 by 38 millimeter field of view with more than 16 million pixels at 9 microns per pixel. Anyway, and we combined it with 3 nanometer Astrodon H alpha filters. The entire optical system gives us 3.1 arc seconds per pixel. And they're located in New Mexico skies, which gets much more clearer dark skies than we do up here. Anyway, Dennis went to work building on building the imaging rigs. Okay, these aren't like filter wheels in your regular telescopes. We wanted these things to be very maintenance free. So, and to keep dust off of all the internal surfaces, this is a sealed tube setup with just one filter and no moving parts there besides the focuser. So, and instead of a filter wheel, yeah, like I just said, it's custom mounted 3 nanometer filter. Anyway, these are the parts as Dennis was machining them. Dennis has a fully operational machine shop. It's pretty awesome. And this is the filter in place before it's all sealed up and put together. And this was our test rig when we were seeing if everything worked. The focuser was replaced with a FLI PDF, I believe, that device between the camera and the back end of the telescope. You see there's no rack and pinion focuser. Everything is remote and keeps dust out. This is everything all shiny, anodized, and ready to go. We're using obviously also a guide scope setup, but I'm not actually sure that guiding is terribly necessary on the mounts we're using. Anyway, beyond that, planning to shoot the entire sky is actually a little more difficult than simply just, pointing at a bunch of places in the sky. Most mosaicing software doesn't consider the curvature of the sky. The original version of the Sky X had a mosaicing function that you would use for shooting like a mosaic of M31, say, and it did well, for a field of view of that small, of like a couple of degrees. But once it moved on beyond the about 10 degrees, you started to get rotation built up into all of your fields. So we had to reapproach how this was put together. Steve Bisk developed a new robust mosaic planner, allowing us to plot up all our fields and actually see the correct overlap in the Sky X Pro. And this is how our initial plans went. We actually changed it a little bit after this point, but you get the idea. There's a lot we're going to be shooting, as you'll see. Anyway, after several months of testing, we began operations in mid-June 2016. And these are the scopes on the two Paramount MEs, I believe, running everything remotely. We're controlling these using a DC3 Dreams ACP software. That's astronomy control panel. Basically, program in all of these fields and we can, knock them off as they're shot. Anyway, we're currently shooting from New Mexico skies. We can see all the way down to -32 declination. That's about 70% of the entire sky. And that's pretty good. Anyway, the entire sky in our field, our plan requires 4,000, I think it's 4,120 to be precise, but 4,000 is close enough for right now. Anyway, and each of these are going to be 12 20-minute exposures. Again, 4 hours, which is really deep when you're in an exceedingly dark sky. Unfortunately, not long after we commenced operation, David was stricken with an aggressive form of cancer. To help lift David's spirits while undergoing his treatment, Dennis and I elected to put together what data we were accumulating and put a website together so we could watch our progress. Anyway, this was in March 2017. This was our barely 10 months into the project. We were already getting a pretty good field coverage of the Milky Way. What you're looking at in this particular image is you'll see Cygnus on the right-hand side and Sagitta way at the far right. And this spans all the way to Auriga and Gemini on the far left side. One of the things that we found were these really faint tendrils of hydrogen nebulosity permeating a lot of the northern sky that you don't normally associate with nebulosity. Like this is an area around M31, which we were given an APOD for when we released this image. Unfortunately, David did pass away on May in 2017. But he left plans for all of his projects to continue, and his family is extremely supportive of it. And we continue to work through the project. Asteroid 16779 Mittelman is named in David's honor by Dennis Cicco himself. We had estimated this project to be about 5 years, but it's looking more like it's going to take 8 years because we didn't account for having to reshoot a lot of fields because of weather and equipment problems. The equipment's been working very well, but we did have one camera fail briefly. FLA, by the way, has been extremely helpful and quick in getting us back onto the back up and running. In the past 5.75 years now, we've accumulated 4 terabytes of data. That's a lot of images, okay, and completed nearly 70% of the entire project. As of today, actually, this is outdated. I forgot to update it this morning. We actually have 2,488 fields of 4,100 completed. There's only 3,178 visible from New Mexico skies, and I say only. It's just amazing how much data we're getting. And due to the nature of the script that we're using, the survey targets the best placed fields each night in 1-hour blocks, okay? So it'll shoot 3 20-minute exposures of say, field 1136, and then move on to the next best field that was available that night. So it doesn't just concentrate on one field until it's done. And therefore, we have a lot more than just those completed fields. We have a lot of fields that have 75% of the data completed, or 50%, or even 25%. There's only about 3 dozen fields visible from the Northern Hemisphere that we haven't actually targeted yet, though I expect them to actually be swept up this spring. They give you an idea of what this data looks like when you start collecting it all. I mean, this is just one of the folders, and this was a long time ago. It only says I have 581 images in this one folder. That folder is now about 2,700 images. Anyway, here's a couple of the early results that we got while shooting this. This is an object in Lacerda called SH2-126 on Sharpless, the second list of nebula, emission nebula in the sky. To give you an idea how big this particular field is, we also completed the entire constellation. And eventually, we plan on releasing all of this data publicly for free for anybody to be able to download. To stitch it all together, though, is a little unmanageable for me at the moment. So I'm currently assembling each constellation individually, and we'll be releasing them in that form. To give you an idea of the difference in resolution between the 110 millimeter lens and the 127, this is the same object. Taken with the 110 millimeter lens here, and this is taken with our survey scopes, the AP130s. Okay, as you can see, the stars start to really get out of the way, and you can really see the faint structures behind them or around them. Again, here's another comparison. Here's the Seagull Nebula, which I thought was pretty impressive. But look at the filamentary structure we're resolving now using this higher resolution setup.
That's amazing.
If you look at the lower middle, that bright object is Thor's helmet.
I think Lydell's photographed that.
Yeah, probably.
I believe
saw
I've
that
seen
too.
It didn't look that good, John.
Can anybody guess what part of the sky we're looking at here in this
Oh, boy.
particular image? Probably not, but okay. Anyway, to give you an idea, that bright star is Vega, okay? And you're looking at the entire constellation of Lyra, anyway, in hydrogen alpha light. And what's amazing is how permeated it is with faint tendrils of nebulosity that reach out from Cygnus all the way out to, it looks like it's reaching out to Vega, but I believe it's unassociated. This is the constellation Sagitta. I've drawn the lines on it. What's interesting here, I particularly like this field, is that here it is without it cropped. The bright object you see in the upper right, that's the Dumbbell Nebula. And within that faint cloud on the left side is the open cluster, or it's some have thought it's a loose globular cluster. That's M71. What's interesting is that it's surrounded by this nebulosity that it's definitely being burned away by the cluster itself. Here's a object in who's it, Cassiopeia, or in the edge of Cepheus, called Cedarblad 214. To give you an idea of where it is in perspective, this is almost all of the constellation of Cassiopeia shown here. And what again fascinates me is not just the bright showy objects, but all these faint tendrils that seem to connect a lot of these objects together. Here's the entire constellation of Cassiopeia to give you an idea, with the lines in place and comparing the two. It also, if you notice, if you're looking at this image with, let me go back to, for Cassiopeia, on the left-hand side, you can see the double cluster of stars there. Anyway, it's surrounded by this faint nebulosity, and it really gives you a different perspective on these objects. Now, when you shoot it really deep, the double cluster can get even more interesting surrounded when you reveal a lot of the faintness around it. It gives it kind of a different perspective, I think. Right. And here's again the Veil Nebula. Here's the entire thing in our field. This is about I believe this is 9 panels of our survey stitched together. One thing that I've discovered recently is that a lot of these objects you can see even better when you remove the stars from them. You can really see the faint extensions of where this nebula really is bordered, and it gives you, particularly in this image of the veil with the stars removed. I mean, I haven't really processed it differently here. Between this one, I've just taken out the stars, and it's a wider field of view. But you can see all of this really faint stuff, and it gives it a very three-dimensional feel, I believe. Here's an object called Sivan 2. You saw it earlier in the slide with M31. That was that big blob near M31. Anyway, it was discovered in 1972, I believe, and nobody photographed it since then until, well, we picked it up on this one. Here's again is a part of Cassiopeia and into Camelopardalis. What's really interesting here, besides the extent of the Heart and Soul Nebula, and again, you can see the double cluster at the bottom right there, but there's all these faint sharpless objects at the bottom left of the image. But I was particularly impressed with at the top right, top left there, that large faint nebula with the bow shock in the middle is the star Alpha Camelopardalis, I believe, is moving through the interstellar medium there and creating that bow shock. And it really shows up interesting when you remove the stars. Once again, you can see a lot of this extremely faint nebulosity even jumps out further. Here's an interesting area in Orion, Gemini. Here's it's IC 443 and 444 in the middle. That's a supernova remnant in the middle there. You also see what's informally known as the Monkey Head Nebula. I think that's NGC 2174 in the bottom right. But that's actually in surrounded itself by an even larger nebula that's known as the I believe it's called the Orion Ring, or Orion Gemini Ring. And when I remove the stars and bring it out, you can see this large structure surrounding the entire area there. Particularly interesting are those bow shocks at the lower middle there. This is the stuff that fascinates me and that I'm really interested in, and essentially why I wanted to get involved in this survey. This is the area around the Eagle Nebula, M17, right in the middle there, or M16, sorry. And but it also has those bow shocks. It's got a ring front around it. These are large supernova remnants, ancient supernova remnants that are known only until recently through radio images. I don't know if anyone recognizes this, but this is a California nebula when you go really deep in H alpha. I think it looks more like a scimitar myself. Here's a familiar area in Cygnus with the Crescent Nebula NGC 6888 on the right-hand side. The Butterfly Nebula in the middle there, whose number escapes me at the moment, but anyway, is on the left-hand side there. But to put it into context, here's the entire constellation of Cygnus, which is absolutely riddled with nebulosity, and it seems to make a nice shell around where the the North America and Pelican Nebula are in the in the middle left there. And as you can see at the bottom is the Veil Nebula. This will give you an idea of the image scale that our survey is shooting. We still resolve a lot of the very smaller objects, like here's the Crab Nebula. And this is M83, the galaxy in, what was that, Hydra, I believe. Anyway, but a lot of galaxies actually have a lot of hydrogen nebulosity, you know, around the starbirth areas. Anyway, what's cool is the image scale of this survey lends itself, as I said, to reveal these large structures not visible with lower resolution instruments. And professional astronomers tend to take notice. While assembling a mosaic of fields in northern Cepheus, I noticed bow shocks that continue through several fields. And this is the image right here. I mean, it's really noisy, but this is really faint stuff. Anyway, Dennis did some research and found this to be a suspected supernova remnant known as G107.0 plus 9.0. Those are actually galactic coordinates. But anyway, it was discovered on ROSA X-ray data. All right. When I processed this image and posted on our website, we call it, our image was the first object of it recorded at optical wavelengths, and our data led to the identification of the brighter areas where spectra could be obtained with a large observatory class instruments, allowing the MDW Sky Survey to be part of the discovery and verification of the object's identity. Anyway, and that was our first pairing with Dr. Robert A. Fesson of Dartmouth College. He specializes in studying a lot of these faint supernova remnants, and it gave us credit on some of these discoveries. You might have seen this paper recently published. Well, we got our name on it too. Another one that we that I found on our data was G70. I'll just call it G70. That's as much as it's going to roll off the tongue. Anyway, this also was the subject of a paper, and as you see, our names: Dennis Cicco, David Mittelman, and Sean Walker. Yay, published.
Congratulations. Yeah. Good
Thanks.
job.
Another thing that we were party to the discovery of is this extremely large supernova. It's a bow shock passing through near Earth, actually, in the northern part of the sky, and it's called the Ursa Major Arc. All right, what it is it's a big nebula. That one's particularly bright not bright, but 30 degrees long. All right, again, we got credited on this, but to give you an idea, we reported on it again. But as you can see, it traces out to be this massive area in covering several constellations in the northern sky. By the way, let me just scroll back to it. This is the image is shown in negative, and you can probably see the arcs, but at the very extreme left of the image, the two black spots at the edge of that corner there are M81 and M82. So there's a little ballpark landmark for you if you want to try and find this stuff yourself. Okay, and here's another bow shock. This is I can't remember the name of this particular one, but again, this is a mosaic of about 8 to 10 of our fields to show this stuff. Again, as I was mentioning, the 3.1 arc seconds per pixel helps reveal faint structures, but sometimes they're barely there. I'm not sure if you can actually see, there's a little bit of a brightening in the middle right of the image here. When you subtract the stars from the image, oftentimes it can reveal some of these faint structures even better. This happened to be an object called Supernova Remnant G181. Anyway, it was only discovered in 2016 at radio wavelengths. My photograph here that you see is the first image taken at optical wavelengths, and it's going to be the subject of an upcoming paper that'll be published in the early spring. Okay. Spring this year, we're going to be moving one of the first scopes down into Australia so that we can start picking up the last 1,000 fields in the Southern Hemisphere, followed by AP2, the second scope. The reason we're not moving both at once is there's a lot of fields that we have to finish up on, and we want to keep one of them going while it takes quite a bit of time to move and recommission the scope when it's in position there. So we want to stagger it so that we're still getting data as we're continuing on. And I'm really looking forward to seeing what's in those things. Anyway, any questions?
Well, wait a second. Thank you so much. Sean, you have taken so many familiar areas to us and exposed it to us in a way I've never seen them before. I almost feel like I'm looking at the sky in a whole new language. I really appreciate you sharing this with us and taking the time to point out some of the sites there too. That was great. I was shocked by some of this.
Yeah, that was amazing. Thank you very much.
Yeah, as Dave said in one of the comments, there's so much of that dust and gas out there. We never imagined there was that much out there. I've even done talks about interstellar gas and dust and the solar nebula and all. Man, I wish I had some of those images, that I could have used in school to help share that. And you're right, you know, the planetarium does have an overlay in most of the planetariums where you can show the Milky Way and you can show the different frequencies of light there, but nothing like what you're collecting there. So thank you so much.
Well, if you're making talks for your presentations for your observatory and whatnot, all of our images are freely downloadable off of our website at mdwskysurvey.org.
Right. Can someone catch that address for us? Because what I'd like to
I'll
do
send you the link today, Ted.
okay, because what I'll do is your talk here will stay on our website for a couple of years. So we'll put a link to that there. So when people stumble over at the website, maybe they'll get out to you also. Okay, Sean?
Okay.
Did anybody else in the group?
A question for you.
Yeah.
Go for it.
Have you had any problems with the SpaceX satellites in your imaging?
No, not really. I see a lot of satellites, but in our data, but we planned on satellites being in them because, you know, yes, there's a lot of SpaceX satellites, but there's a lot of other stuff that have been up there already. And the way we built our imaging program is that we're combining a dozen sub-exposures to be able to reject satellite trails and spurious data. We actually get a lot of faint meteors too.
Yeah.
Let me do a quick follow-up on that. I may have missed it or maybe not, but a quick explanation of how you eliminate the stars to see the nebulosity behind them.
To remove the stars? Oh, okay.
When you
Yep. There's a free program called starnet.win that you can download, and it's either you can run it standalone as I do, or it's a module you can plug into PixInsight, and it automatically identifies and erases stars. What it does is averages the data around it to fill in the areas, and it does a very nice job.
very
Ted
good.
just
Okay.
came out with the second version of that too, Sean.
Yeah, I know. I just downloaded it, and it's about
Yeah, I got it the other
4
day.
times as fast as the original one too.
It's faster and it's more efficient.
Yep.
It's a beautiful job. I think the question I had was, what we got into why you guys started doing this, but what prompted the initial thought of doing hydrogen alpha?
Well, first off, when we first started our projects, we were shooting in New England, about 20 miles outside of Boston. So if you wanted to get beyond, you know, the Messier objects, narrowband imaging, you know, is really a great gateway for people in urban areas. Okay. However, let me just say that shooting from a narrowband from a dark sky, there is no replacement for a dark sky. You can get far deeper with far less images.
Far less time also.
Yeah, exactly.
Any other quick questions out there?
I don't have a question, just a comment that just goes to show the difference between amateur astronomers and professional astronomers. Amateurs don't have to play around waiting for a federal grant, and they can sort of change the rules and turn on their heel, and you never know what you're going to get.
Yeah, although, I mean, let me just say that, you know, David was the prime mover of our project, and without him, we couldn't have afforded to do the work that we're doing right now. And by the good graces of their family, that the work is continuing, and it's very exciting. And yeah, I really wish he had lived to be able to see it.
It was his labor of love, and you guys
Yep.
can continue it on. Congratulations. I admire you for doing that for him too. He's out there. He's hearing this. Anyhow, I'd like to, before I cut off our YouTube, I'd like to say to our worldwide audience, we are the Rittenhouse Astronomical Society. And if you just tuned into us, we are a business. And although we say that we are a nonprofit business, we run as a not-for-profit. There's nobody here collecting a salary. There's no paid officers for us. So if you like what you see, you'll go up here to where it says donate to Rittenhouse Astronomical Society. And what we're going to do is we're going to stop the YouTube feed in just a moment, because our members will continue on. We have something we call the Planet Report. We also have rocket science that we'll do. And we also have a feature that we do a little bit of AstroCora, where our members get to just bring up general astronomy questions. So again, I'd like to thank you for joining one of the oldest astronomy societies in the country. And I'm going to see if I can find the button now to turn off our YouTube feed. And I think I